The Australian Standard 2293 for exit signage and emergency lighting states in its foreword, "It is recognised that the presence of smoke will have a detrimental effect on the visual conditions provided by emergency lighting." The committee is of the view that there is no practical way of ensuring that the lighting system will continue to be effective under smoke conditions, and that dependence must be placed on other measures such as building construction and ventilation to keep escape paths as free as possible from smoke. It goes on to state, "There are developing techniques, for example wayfinding systems, that when applied to escape routes in addition to conventional emergency evacuation lighting, can enhance the visual guidance afforded during an emergency involving loss of the normal lighting. These techniques are not covered in this standard." Internationally, photoluminescence has already been adopted in countries like the United Kingdom, Europe, Japan, Canada, South America, and various parts of the United States. It is mandatory in industries such as aviation and marine vessels worldwide. The nature of an emergency lighting system is such that one can never predict when it may be called upon to function. Consequently, although it is important that the system is correctly installed and initially operates satisfactorily, it is equally important that regular inspection and maintenance procedures are instituted to ensure that the system will be in a state of readiness for operation at all times. On September the 16th, 2008, signifying a shift toward enhanced high-rise building evacuation in the post-9/11 environment, the International Code Council revised the International Fire Code to include New York City's standards requiring the installation of glow-in-the-dark path markings in the stairwells of new and existing high-rise buildings over 75 feet tall. The code will go into effect January 1, 2009. Designed to glow in the dark when emergency generators and lighting fails, photoluminescent path markings enable people inside buildings to safely use enclosed staircases in the event of emergency evacuation. Under new requirements, photoluminescent strips will be placed on steps, handrails, and the perimeter of enclosed stairwells in new high-rise buildings in municipalities across the country that use the International Building Code. Two events led to New York City and ultimately the International Building Code requiring the inclusion of glow-in-the-dark path markings in stairwells of high-rise buildings. First, according to the National Institute of Standards and Technology's final report on the 9/11 disaster, World Trade Center evacuees said that photoluminescent markings guided them out of the towers quickly. The markings were installed in the towers after the 1993 bombings. The second influencing event was the August 2003 blackout, which left a good portion of the Northeast without electrical power. In New York, the emergency electrical backup systems in many buildings failed, typically due to poor maintenance, faulty batteries and generators, or improper installation. Without this emergency power, people were stranded in buildings, unable or scared to make their way down the exit stairs. The human eye is most sensitive to the yellow-green region of the colour spectrum. During the period of darkness, the eye of an average person will adapt to the darkness at a rate roughly matching the decrease in luminous intensity. When the source of light suddenly goes off, photoluminescent materials glow strongly. After an initial decline in brightness, the glow settles to a near-continual intensity. The human eye adapts to the reduction in brightness, and for quite some time the increasing optical sensitivity of the eye makes up for the intensity decline of the photoluminescent material, which provides an extended visibility duration until reabsorbing becomes necessary. A positive lifesaver during the evacuation of buildings in the case of fire or other sudden emergencies. Pathway marking is also capable of replacing overhead emergency lighting. It does not matter how bright emergency lighting was designed to be if it is not operating or cannot penetrate the smoke. Smoke causes more loss of life than any other element. One reason is that people become trapped when they cannot find familiar landmarks and subsequently succumb to toxic gases, heat and flames. Without respiratory protection, the time available in severe smoke is approximately 50 seconds at a mean travel speed of 0.35 meters per second. This corresponds to 17.5 meters that the average person can move in smoke before they succumb to its toxic elements. We are talking about sufficient light to be able to safely evacuate a building. Designed for initial critical movement time, the initial luminance level at power off is 81,000 millicandela per square metre, or over 200,000 times above human eye visibility threshold. After the first 15 minutes, 90 millicandela per square metre, or 250 times above human eye visibility threshold, is provided. As those in the know will tell you, if you're not evacuated within 15 minutes, then you'd better be part of the rescue team. At 90 minutes, delivered light is 50 times greater than human eye visibility threshold. While electrically powered systems can be designed to be brighter than photoluminescent materials, they can never be as reliable. Throughout Australia, there are increasing numbers of high-rise buildings, underground road tunnels and rail systems. Most inner-city transit systems have their stations located underground, beneath commercial buildings, and all are being lit by fluorescent lighting systems. History has shown that in actual emergencies, when power is suddenly lost or during tests, the emergency lighting systems were either non-existent or defective due to equipment failure, lack of maintenance or vandalism. With inadequate numbers of emergency lights installed to safely illuminate corridors, pathways, waiting areas or exit passageways when power is suddenly lost. This poses a major safety threat to people in darkened buildings, waiting on station platforms, walking through underground corridors or evacuating through exit tunnels. All of these people must do so in almost total darkness and can only truly evacuate safely when assisted by the emergency personnel with flashlights and lanterns. This should not be occurring, as there is a simple and cost-effective method to provide fail-safe lighting for all emergencies. Lumenite light sleeves should be used on all fluorescent lighting fixtures throughout buildings and transit systems to illuminate hallways, stairwells, corridors, lifts, exit routes, fire escapes, tunnels, as well as train platforms and in carriages. Light sleeves are ideally installed on approximately 25% of all fluorescent fixtures throughout a location, so in the event of sudden power failure, the occupants are never left totally in the dark or subjected to dangerous blackout situations. The Lumenite light sleeve is best described as lighting for seeing, becoming a pathfinder light to be seen. The Lumenite light sleeve allows the host light fitting to perform normally under powered conditions and provides sufficient illumination when the lights go out to allow for the safe and speedy evacuation of persons from any location. It is 100% fail-safe, reliable evacuation illumination that provides extended duration visual guidance after covering the critical initial power outage stage with adequate evacuation lighting. In other words, lighting that allows you to see your way, which turns into visual egress markers to show you the way. You would not put an emergency light in every room or office, as the cost would be prohibitive, but you could use light sleeves. The sleeves make it possible to illuminate the complete exit route, providing for the safe, orderly and speedy evacuation of buildings in blackout conditions. The green glow produced by the light sleeve is also its environmental credentials, as simply installing a few sleeves could eliminate 1 to 2 batteries per floor per building. Multiply that by the number of buildings per town, per city, per state, and you soon get an environmental benefit of massive proportions. The light sleeve is well suited for applications where the sudden loss of light is a threat to safety and security. The sleeve's unique feature of always on means there is no period without light after loss of power supply. Vandalism or a catastrophic event can destroy the lighting fixture, but it will not render the sleeve ineffective. Once charged, the sleeve continues to perform its role. Whatever the location, the light sleeve can add to the safety and security of all those within. The Lumenite light sleeve, always on.